In the introduction, right? Now, why do we use Python, right? It's a big buzzword in the industry. And some of you might also be doing some amount of what we say Python programming. So moving forward, why do we do Python right now? Or before that, what is Python, right? So Python is basically a backend programming language, high level, approachable for beginners, has a welcoming and established community, right? So it's a very big community and it's a backend programming language. However, the kind of things that you can do with it is like you can do web development, scripting, web scraping, data analysis, and automation. So there's a wide variety, if not many of the things Python can actually do it, right? You might be surprised to know some of the things, like some of the most famous tools that we use, like Google or Pinterest or Spotify or Dropbox, even YouTube, are used by companies. I mean, are built on these on the Python technology, right? And then frameworks like Django, Flask, and Jupyter notebooks sitting on top of Python help us basically do all these tasks, right? So that's basically in Python. Now, in Python, you're going to come across a lot of libraries. So things like, Python is obviously the base version that you use. That's the backend programming language. However, since the community is there and they have, repurposed or packaged codes and libraries that can be reused by the community for certain tasks, which are widely acceptable by, are getting done in the industry. So because of those libraries, it enhances the functionalities of Python, right? So we are going to come across, Pandas, Matplotlib, right? Pandas is going to be a data manipulation, right? You're going to use Matplotlib for charting, Scikit-learn for machine learning. There's SciPy, NumPy again for mathematics. There is Buka and D3JS, which is basically again, advanced charting and all of that sorts, right? So these are some of the things that you're going to be using, right? So I just want you to be familiar with that particular point. Now, why learn Python? Python is one of these languages that is versatile, and it's basically has some of these features, right? The ease of use. Some people find it is difficult, but the more you use it, it's that easy to use it, right? As I said, libraries, it's used for machine learning, extensible, embeddable, right? It works with Raspberry Pis for IoT, speed, there's web development, server-side scripting, and a lot of other things, right? So there is so many things that you need to take care of. Yeah, and reduces complexity, that's right. Now, in terms of salary indicators, again, this is an indicator, right? It does not mean that this is exactly the figure that you're going to get. It depends on where you are, how you speak. There's a lot of other factors, but the idea here is to compare the level of income that you will have if you use it for data science, right? For data science, you're going to see that approximate 8 lakh is what you're going to earn for data science when you are in this particular industry, right? And this is nothing but for anybody between 1 to 3 years of experience, right? So that's the level of scale you're looking, and you can compare it with others, and you'll see that your package is much more better, right? So obviously the opportunities that you have with working with Python and data science, it's going to be a lot.
Hello, in this video I'm going to teach you how to download Anaconda and set it up for running Python codes. So first you have to visit anaconda.com. The spelling is anaconda.com. So once you visit this site, you're going to see download the Anaconda offerings here, and then you can download the Anaconda distribution. Say download now. Now, before you download, please ensure you have at least 8 GB of RAM and i5 processor for Anaconda to work properly. and smoothly. If you have anything below that, it still works. However, it's going to cause a little bit of delays or some trouble executing things quickly, right? So please ensure that you have at least 8 GB of RAM and i5 processor. Now, I know that processors cannot be changed so quickly. So the best thing to do is to upgrade the RAM to at least 8 GB or 16 GB if it is possible, right? So that way you will be able to run all the applications such as Anaconda, R, Excel, SQL properly on your laptop, or else some of these applications can get buggy or crashing very easily. Also ensure you have the latest operating system on your Windows. If the old versions don't work so well with the newer distributions. So yeah, that's some of the precursors there. Okay, so now that you know about this background, what you can do is there is a 3.7 version and 2.7 version. Previously, companies used to use 2.7 version and the 3 version was unstable. However, now the 3.7 version is a lot stable and it's a lot better, right? So you can definitely start using this particular thing. Okay, so this is for the Mac OS installer, right? There is for Windows also, right? This is for Mac OS, and there is for Linux if you are using Linux, right? There's nothing better than working on Linux with Python or Mac OS. But if you're on a Windows user, the installation is going to be very simple. What you have to do is Python 3.0 version. You can choose 64-bit or 32-bit based on your requirement, right? So if you do 64-bit, it's going to download this application. Okay, so once the application is downloaded, what you can do is you can click on the exe file and install everything. Once the installation is done, what will happen is you will see in my system it's already done, so you'll see this particular icon coming in, or it's going to be okay, I didn't place it on the desktop, but yeah, you will basically get this particular icon. So you can click on this to launch it. So it's loading. So once it's loaded, it'll give you this pop-up. You can just say okay and do show again. But you'll come to this particular browser. Now, just quick guide on this particular this thing. You have your environment, and this is basically your Python, which is installed. And by default, Python installs all the packages that you require for data science. Anything extra, what you can do is you can just go simply say not installed and look for the particular package you need to install, right? So for example, let's say I have H2O, or let's say Lime, and there is something else, Excel. Yeah, so there is a lot of R, XLSX, read Excel, and all of these files, right? So some of the things, some of the packages are not installed, but if in case you don't have anything available and something that I used during the courses, you can come to this particular say not installed and install it, right? Right now this is the installed one, and in this mostly all the packages such as NumPy, right? NumPy, Panda, Matplotlib, right? All of these are available. So that's one of the things. You can also create multiple environments. So in case you want to do, so I basically have one more environment for web scraping. This is specifically to those packages that are used for web scraping, right? So you can have multiple environments ready with different set of packages that will help you to work on various set of projects. So that's a brief on this environments. You can launch the terminal here, or is it open terminal, open with Python, open with IPython, or open with Jupyter Notebook. Open terminal is the one that you want to used to basically run this instance of Python within the terminal. Okay, going back to home, we're going to mostly be using the Jupyter notebook, right? And with it we have VS Code, Spider, and these are again used for automations. But learning, we just go with Jupyter notebook because it is inline coding and writing, right? So I'm going to say launch, and it automatically opens it with your browser. Now once you open this, what happens is that basically the file structure that you have under documents, not documents, basically under your this PC is visible here, right? So if I go to documents, right, just like I have within this place documents, I have all the folders that are present here um, within this particular place, right? So what this means is now is that I can create one folder here. Let's say I'll say Python course, right? And the same folder will now be visible here, right? So it's called Python course. Right now nothing is visible here. If you want to open a new code here, you can say Python node Python 3 here, and it basically opens a code here. You can say first code and say rename. So once you do that, you can simply say import pandas as pd, run the code, and it imports a particular library. You can say 2 plus 3 and run the code, and it basically runs the code. If you want to add a cell below, you can say escape below, escape above. That's the thing. If you want to delete a cell, it's escape delete. That is escape dd, right? Escape dd is the command. If you want to see more of the shortcuts, you can say keyboard shortcuts and have a look at all the shortcuts that are available. I highly invite you to learn some of the keyboard shortcuts that are really important. So once you do this, what will happen is it will list the Python codes that are there within that thing, and it will also create a IPYNB file which can be used to share or save these Jupyter notebooks, right? The other thing is you can also copy and paste already have all the materials that are available, right? So for our use. So for example, in these classes we're going to use some of these. So I'll be giving you this particular files in a zip, and you can download them, place them in one folder, copy them, and place it in the same folder that I have here, like Python course. So when you paste it, it is basically, if you refresh this page, it will basically be available here. So you can just launch it, right? Okay, that has just images. You can launch this, and it basically loads the entire code that is available, right? So that way, whatever files I'm working on, you can quickly open these files and start working on them also, right? So this way it will help us stay on course and utilize be hands-on rather than just listening. Okay, so yeah, that's about it. One more idea I have. So whenever you start a particular code, right, I always invite you to file, save as, right, and give it a new name. Let's say first code, and give it a date like 18th May 2019. Okay, no such file directory. Okay, it doesn't do that. Make a copy. Best way to do is make a copy because of that thing, and then yeah, you can just rename this to basically say 18th May 2019, and then it saves that particular code in this place. So basically you will have, if you sort this in descending order, you'll have a working copy, and you'll have the latest version without any errors, right? So I often save a copy if I have no errors within that file. It's all very often to lose a code in this industry, so it's always easy to keep a copy of the files that you're working right? Make a copy and work on that file so that you have a backup of the copy that is original. So yeah, so that's about it. Now, once you've set up this and are able to open a file, write some codes like this, we're going to then start the Python basics. So I'm excited to see you there in these sessions.
In this first video, we're going to learn about Python data types and its basic operation. I'm in the folder 2Python, 1-Python basics, and I'm using the notebook Python basics. So I've already opened the notebook. In this particular notebook, we're going to look at the basic forms of data types within Python. And the first type is integers. So I have two different variables, x and y, within which I have assigned x4 and then y2. I can add them by typing print open bracket x plus y and close bracket. You can notice that both of them are enclosed within an open bracket and closed bracket. So if I run this particular code, it's just going to take these two numbers and add them. The result is going to be 6. Moving on, the second data type is floats. As you can note, I have x is equal to 4.3, y is equal to 2.3, and I can add them like the example below. I can also subtract them using the minus symbol. I can multiply using the star or asterisk symbol. I can also divide the values, that is x divided by y. I can also return the remainder by saying x percentage y, and it is going to give the remainder. I have absolute value, that is print within the rounded brackets absolute of ABS of x open and close brackets. So that's going to give me the absolute value. Also, I can say x to the power of y, which is going to give me 4.3 to the power of 2.3. So let's run the code. As you can see, I'm getting 6.6 as an outcome. Addition is going to give me some other outcome. Division is going to give me some other outcome, and so on and so forth. These are the basic operations. Now, the third data type is string. Now, this is what the building blocks of Python looks like. So let me assign two different strings to x and y. X is equal to fun, y is equal to excel. Now, when Python looks at any string variable, what it does is it interprets that now, instead of doing addition like numbers, I need to concatenate these. So for example, if x contains fun, y contains excel, and I'm giving a string, the static string here, it's going to concatenate x, the static string, and excel. So it's going to be fun into excel. I can also say x into 2, and it's basically going to repeat fun 2 times. If I run this code, you're going to see I'm going to get fun into excel and fun, which is nothing but repeating x 2 times. Now let's go further deep into string and what it can be done. I can do string selection or range slicing by using square bracket. Now square bracket basically gives an idea that, hey, I have a list with me and I want to pick certain elements from that particular list, right? So in this case, I have a string my name, that is KUNAAL, and I can say my name to colon, and then I can leave the next value here. If I say 4, it's going to say 224. But I'm just going to leave that value there, and this basically tells me that, hey, I want from the second character onwards towards the end, or second letter onwards towards the end. So for example, if you consider K to be 0, U to be 1, and N to be 2, so from 2 till the end, that will be NAAL, right? So I want that particular character. I can print that. I can also slice it, so I can take the only one letter from that particular string, and in this case, K0 will mean K, 5 would mean L. So if I add both of this, obviously it knows it's string, so it's going to concatenate and it's going to give me KL. If I run this code, you will see I'll get NAL for the first example and KL for the next example. Now what happens if we have numbers as string. So if you put the quotation and put a number and then assign it to X, you will notice that it's going to treat these numbers as string. So if I run it, instead of addition, it's basically going to concatenate these two string numbers. So if I run it, I'll get 21. Notice only when you assign it without any quotation will it treat it as either integer or float. Moving forward, I can do basic things like capitalizing a particular string. I can say string, that is a default within Python, and then within it there is something called as capitalize. So I can take a string and then capitalize it. So for example, I have taken a static string that is elephant. I can capitalize this to capital E-L-E-P-H-A-N-T. So if I do that, you will see that E will be capitalized, right? I can also pass any variable within this to capitalize it. This is just an example. So in the next example, I also have things like finding the length of a string. So in this particular case, I have string 1, which says we love data science, and I want to know how many characters are there within this particular string. I can simply say length, open bracket and close brackets, is string 1, and it's going to give me the length, right? So there are around 20 characters within this particular string. Also, I can check whether each of the string is digital. Notice in string 2, I have 404, which is a number, but again stored within string 2 as string. So let's see what Python is going to do. So for the first one, obviously it's not going to be digit, so it's going to be giving me false. And string 2, right, ideally we would expect that it should give me false, but since it contains a particular string, it's going to say true, right? So, and in totality, right? So if we had probably a character, let's see what it's going to do, right? So I'm going to rerun this and run this again. You will see it's going to be giving me false, right? So when a number present within quotation in totality, Python treats that as a number. Let me rerun it and let me run this particular thing, and you will see that it's going to give me a true. Moving on, I can do things like replace. So for example, I want to replace love with like. I can say string 1, this particular string dot replace love with like, right? So string 3 contains like. I can also type it here, but it's always better to have it stored in a particular variable and then use it. If I run this, we're going to get a sentence called we like data science. Now let's find where the love is present within this particular sentence. So it's present in the 0, 1, 2 and 3 position. So ideally this particular answer should be 3, right? So it basically finds where LOV first occurs and then returns that particular position. Now let's look at string 1 again. Since I didn't assign it into a different variable, right, the original value is going to remain we love data science, right? If I did assign it to some other particular variable, I would be able to access it, but for now I did not assign it. I just basically replaced it and then displayed it, right? So we can do one-off things like this, or you can choose to assign it to a particular variable, right? So if I chose to assign it to a particular variable as string 4, it's not going to do anything. However, if I say string 4 value, it's going to show it, right? So that's how this particular replace works. I'm just going to leave it as is. Okay, so next thing, the fourth basic type of variable that we have within Python is Boolean. That is basically it holds true or false. So I have two different variables, x is equal to 4, y is equal to 2, and I can say z is equal to x double equal to y. That means it's basically a comparison operator. I'm trying to see whether each of these values are equal or not. Then I applied a if statement
if z, that is if z is either true or false, colon, and then I gave a sentence that is print we want to be data scientist, right? Else print we do not want to be data scientist. So if this particular condition is true, then this will be printed, else it's going to print this particular sentence. So if I run this code, let's say it says we do not want to be a data scientist, right? I can also simply replace this with 4, rerun the code, and you will see that we want to be data scientist will be printed, because now this particular value becomes true. So we leave this as 2. Okay, now the other thing that I want to cover in this particular example is that whenever you come across numbers, strings interchangeably, right, you're going to come across some different types of implicit conversion. So for example, in X I have 6.0 and Y I have 3. These are two different data types. So ideally, what is the expectation here is that if I divide X by Y, the expected answer is going to be in decimals. Hence, what Python is going to do is automatically convert the output of X divided by Y to a float, right? So this is intuitive for Python to do it. Hence, it does it automatically. However, when first let me just run this code. So if you notice that the type of Z will ultimately be ending up as float, and we can use the function type, open bracket, close bracket, and give the variable, and it's going to give me the type of that particular variable. Now the other part is explicit conversion. Now when you give Python X is equal to 8 and Y is equal to a particular sentence, right, it does not know what particular variable to convert to which type. So for example, should it convert to 8 to string, or should it convert the string to a number? And this cannot be done because this is a string, and how would you convert a string to a number, right? So this is not possible. So basically, when you run this particular code, you're going to get an error because, right, it does not know what to do, right? So it's going to say type error saying must be string, not int. So what we can do is that we can say the same variables, assign the same values there, but we're going to do an explicit conversion. So what we have to do is choose what of those variables we need to convert to what. So for example, in this particular case, I meant that I want to say Game of Thrones season 8. So what I'm going to do is I'm going to concatenate Y plus convert that X variable into string and then concatenate it together and display the results, right? So if I do this, you'll see Game of Thrones season 8 is going to be coming, right? So that's how the explicit conversion happens. Now another example of implicit conversion is that if you take two different integers and divide it, obviously the expected answer is a decimal, hence it's automatically going to convert it into floats. So if I run this, it's automatically going to be converting into floats, that is 2.5.
Let's move on to the next topic then. Okay, what is a list and what is an array? List can contain any data type. Array has homogeneous elements. Yes. Same data type. Yes, exactly. The difference between both of these guys is the kind of data type you have within it, right? So the difference really is going to be this: can hold homogeneous items and can hold heterogeneous items, right? So that's the difference. Yeah, list has different data types. Okay, so which is going to be the faster array? So arrays are going to be faster or lists are going to be faster? Array is going to be faster. Okay, list is not going to be faster because it is holding multiple data types, right? So obviously list is going to be the slower one. Okay, array is going to be fast because it has one data type, and hence it's going to be the faster one. Doesn't really this thing. So in any case, it's still going to be arrays going to be faster. Yeah, because it's for the entire array, it's going to have only one data type, right? But for a heterogeneous one, it has to store the value and the data type, and it has to hold it, even though different or similar are there, it's still going to hold it, right? So that's rational. Okay, cool. So let's look at let's do our first package installs. Import packages. So I'm going to import an array package now. So array package in Python, right? So you can look at this particular thing, and the first link itself, it's automatically give you this, going to give you this particular thing, right? So there are different types of arrays that you can have here, and they are named, right? So you have characters, unsigned characters, signed characters, Pi Unicode, right? Signed short, and a lot of different data types are available here, right? You can quickly go here and see all of the things that are available here, and some examples also will automatically be available there, right? So yeah, so that's arrays. Things like, so you're going to import that particular package, and then we're going to use it, right? But by default, whenever you're going to declare a list, right, and a list is declared by using this square bracket in Python, right? This is an interview question. How do you declare a list, right? So you use the square bracket, right? Remember, functions use this round bracket, but lists, right, are going to use a square bracket. And notice, right, automatically a string is treated as a list in this particular scenario, right? So if you see here, where's that example? See, it's automatically considering that particular this particular thing as a list, right? So it's a particular list which can be accessed by, again, square range, right? So you want to go have the square bracket synonymous, used in different places, but they will mean a little bit different. But again, if you see it that way, it makes sense, right? So by default, whenever you open a square bracket and pass it some values and give it to Python, it's automatically going to treat it as a list first, right? So that's going to be a list. But if you want to convert it, so as you can see here, I passed numbers. Then I can pass number, string, and a number, and then it's still going to be a list, right? So, and I can access a particular part of a list by using the square bracket. So I basically take this particular list and say, give a square bracket, and then give it the index value and access, right? So if I do 0 here, it's going to give me 1. And if I do 1 here, it's basically going to give me apple, right? So it's 0, 1, and 2 in the index, right? So that's there. Now I also have, I can reassign a particular part of a string, and I can do it by simply saying, can you take a particular piece of the list and replace it by a value that is orange, right? So a print x2, and then we have this orange here, right? So I have list numbers. I have again another set of lists and a list of characters, right? I can say list number dot append 11, and it's going to add to the last position, right? So that's something that you can do. You can append certain values to a list, and you can also insert on a certain position. Like for example, in the 0th position, I want to insert a particular number. So I can insert a number in the 0th position also, right? So in this particular position, it's going to insert a number, right? So yeah, that's how we can look at lists, this thing. We can also remove a certain character from a list, and I can just use the remove, right? So as you can see, append, insert, delete are fairly straightforward. You just need to know what the arguments are, right? Now, arrays versus list, as we spoke, this particular time I'm going to declare an array, right? So for example, in this particular scenario, we have an array, and then I can use this A across this code to declare array. So that's what I'm doing here. I'm doing a I want a character array. So I say A dot array, and then I give the U, right? So that U would stand for a type of data type within that array here, right? So U is this particular type. And then I give a list of strings. So which means since I'm doing it through the array, Python automatically understands that this is going to be an array which is of the data type U, and I can then basically see the values right here, right? So if I print it and I said, to string and print it, it's basically going to tell me that, hey, this is a U array, and it basically concatenated all these strings together and then printed it, right? I could just have printed it there, but I just wanted to show an example there, right? Similarly, I can have an integer array, say I, and then I give it 1, 2, 3, 4, 5. The other thing that I can do is again print the array, and it's going to exactly print it like this, right? Right now we don't see the use of it, but right now we are just learning about the building blocks of Python, right? And arrays and lists form a critical part of data science because those are the ones that form, your rows and columns within your data set. So hence, yes, they are going to be a critical part of Python. So now we're going to do tuples. Now this is another data type. So in tuples, now this is where this particular nature of tuples is that is not tuples are immutable, right? Someone said there's immutable type of data types, and tuples are such of them, right? So they're immutable. Once you declare, that is the tuple that it will be there, and the values cannot be changed there, right? So if I declare a tuple, I can get one tuple like this. Again, it is declared by using the round bracket, and you can access it like a list with a square bracket. This remains consistent, right? The only difference that you have is, when you assign a particular value to a tuple, it's going to say tuple object does not support item assignment. So, which means that this is not mutable, right? So that's one of the things that is tuples speciality, right? Then we have something called as sets, right? From the different data types that we had, we did arrays, list, tuples. Now we're going to look at sets, right? So sets is basically you give a square bracket and then you give certain portions, you're going to get a set, right? And you'll notice that sets is declared by curly brackets, like we did it in our 10 standards and all that, right? You remember we did sets, right? And they used to be declared by curly bracket. Same thing, logic continues here, right? But the thing is that, sets contains unique values, and it doesn't really care how it is ordered or not, right? So if I store a value and run it, it's going to give me in a way that it feels necessary, right? So for example, I give it another one, right? And then if I print it, you'll see that it's going to delete the unique, duplicate ones, and it's just going to give me the unique values that are there, right? So yeah, very, very useful for us in terms of, reducing a certain list of values to unique values. This particular thing is very helpful, right? And yeah, sometimes they may be sorted, they may not be sorted, but don't worry about the sort, because yeah, search doesn't really bother about the position. It really bothers about just storing unique values, right? Now only caveat with sets is that you cannot access it by square brackets because it doesn't store it in an ordered form, right? It stores it however it wants to. So we cannot access a set, a portion of a value, right? But however, that doesn't mean that there's no use of this. But yeah, this is the different basic data types, and they have different uses in different places. Okay, so we can just add a particular element to a set, or we can just pop an element to a set, right? The other part, the last type of data set is dictionary. So dictionary, I've not written it. So basically a dictionary can be declared by the curly bracket, right? But the only difference it stores it in a key and a value form, right? So key and value form, right? So the only difference is in a dictionary that it stores in a key and a value. So for example, I can store things like, things like a, or let me do a numerical one. So I'll say 1, and I can store orange, comma 2, colon, and then I can say apple, 3, colon, I can say, banana, right? And it's going to make a dictionary, right? So when I display this dictionary, it's going to be this way, and I can access a dictionary by giving the index number, right? Such as this, and then look at the value also, right? So again, the access remains same, but yeah, the only thing is that it's going to store a key and a value here. Okay. So we're going to use this particular thing in data manipulation and all that, but yeah, dictionaries are a big part of it. Okay, guys, so let's begin NumPy arrays then. Sorry, I just got this thing. Okay, so these are done. So, if your system gets slow, what you can do is you can go here and just shut down these notebooks. You don't want multiple notebooks to be running. So if you shut it down, they're going to be active, but they're just going to be shut down. The process is just going to be shut down. So now you just have one more notebook available for you to run. Okay. Cool. So we have NumPy, and then there's also Stack Overflows post, which is available here, right? And then what we're going to do is have it available for. I mean, there's a lot of things that you can do from this place, but we're just going to run through certain things that are there in NumPy. Now, all the things that we do in NumPy are going to be acting as the building blocks for statistics, right? So if you're doing a course on machine learning and then you are learning basics of like matrix multiplication, and then matrix operations and all of that thing, it's going to be possible through NumPy, right? So that's why NumPy acts as a base. Often, whenever we are doing machine learning, statistics, and all that thing, we load NumPy because a lot of the libraries are built on NumPy, right? Now, again, NumPy is incredibly fast because it uses some of the C libraries, right? So that's something that you need to know. It's fast in terms of doing a lot of mathematical calculation. So very useful in terms of usage for us, right? And again, linear algebra is something that you can also be doing with it, right? So this will already be readily installed. It cannot go with, in data science, at least we cannot go without not using NumPy, right? So we can import NumPy as NP, NumPy as NumPy and as NP. Okay, so here now we saw a version of arrays using this array library, right? Now, but if you're going to also, now the arrays that we're going to deal with NumPy are going to be very different for from the ones that we used in the array library, right? Or by default, like on the default lists within Python, right? So the NumPy arrays have their own special abilities, right? Now, how do you make any default lists within Python to a NumPy array? We begin by first creating a list, right? That is 1, 2, 3, 4. And my list is 1, 2, 3, 4. Now, within that, what we can do is we can say numpy dot array. Notice here we did a dot array, right? And A is basically referring to the array of the array library, right? But what we are doing is taking np dot array and then giving the list, that is by default list, and then converting it into a numpy array, right? So when it converts into a numpy array, it's going to be like this, right? But the only difference you're going to face in this array and this array is that they're going to be both called arrays, but this initial type will not be available visible within this array, right? Or within the numpy array, right? It's just going to be an array like this, right? So you can create a matrix. Now you can see that a lot of things will start unfolding, right? So you can create a matrix such as this. You basically give an array, you create an array, and then you create a list and then put 3 different lists within it, right? And then you say numpy.array and give that matrix, this particular matrix which we assign the value, and then you're basically going to get a matrix in NumPy. Right now, that is ready to be used as NumPy functions and all that thing. So very useful for us. Okay, cool. So moving on, take some time to run. Yes, my system is slow. Okay, anyways, that's going to get you a NumPy array. Now there are some built-in functions to generate arrays. So we have a range with a single R, numpy.arrange, and if you say 0 to 10, it's going to give you 10 numbers, but not the 10th one, that is not 10, right? So it's just going to give you up to 10, but not 10, right? So so that's the thing, and it's going to give you 10 numbers at there, right? So it's basically your start number and your end number. And if you want to know what the argument is, right, you can do shift tab 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 tab, and it should basically give you the, it's not giving me, it's a little slow. Yeah, so if you want to know what the arguments and all that are, you can just use shift tab or just look up within the Python documentation there. Okay, so the next part is arrange with a step of 2, right? So it's going to be 0, 2, 4, 6, 8, 10, right? So that's another array that we have. We have zeros and ones. np.zeros will basically give you with 3, it's going to give you an array with 3 zeros. Now notice that you'll have 0 dot. This is a notation in NumPy, so don't get alarmed by what that is. It's just a 0 and a notation that Python NumPy has adopted, right? Similarly, if you want a 5 by 5 zero matrix, you can just give np.zeros 5 by 5 and you're going to get that particular matrix. np1s is going to be again the similar fashion, and you can also give it a matrix also, right? So you're going to get that very easily. Then you have linspace. very useful for giving, you know, creating charts, samples and all that thing. But yes, again, it's going to be used in a lot of linear algebra also, right? So here in linspace, you can start with 0, end with 10, and then give 3 equal spaced numbers, like evenly spaced numbers between 0 and 10, right? So evenly spaced numbers is going to be 0, 5, 10. 5 minus 0 is 5, 10 minus 5 is 5, right? So that's evenly spaced. Similarly, you can do that into 50 components also. So within 0 to 10, you're going to take 50 components, and you're going to notice that the difference between each of these components is always going to be equal and linear in nature, right? So very useful function. Now as we know, we have this diagonal 1, 1, 1 that we have here, right? So if you just give the number there, it's going to give you these things there, right? Now we have a random. So this is just basically random generators. You have numpy dot random int 1 comma 5. So basically this gives you a random number every time you run this particular code. Okay, this is still running for me. I don't know how much time this guy will take to run. Okay, so basically this generates a random integer. Random generates a number between 0 and 1, and the number of and you can also give how many random numbers you want to generate within a range, right? So that's the thing that you need to keep in mind: random int, random integer. Then you also have a random matrix with 5 comma 5. Again, these random generations are basically used for simulations. A lot of Monte Carlo simulations and all of that thing are based on random generation. So hence this is really useful in that. Okay, cool. So return a sample or samples standard normal distribution. So this is basically random n. Now, if you generally try to generate random numbers, right? The more you the more number of random numbers you generate, let's say random between 1 to 10, right? And if I keep generating, hundreds of random numbers with this particular function, right? And if I just create a histogram on top of it, right, and I just plot it, you're going to see that more or less it's going to be having very similar values, right? It's not like spread as much as a bell curve, right? But when you do it with random n, it basically does into it generates random numbers in a normal distribution, right? So things like let me just show you what a normal distribution is. So your data will basically be distributed something like this, normal distribution, right? So this is your normally distributed data. Ideally, you'll see it's not whatever example we had was not normally distributed, but if you had to generate random numbers with basically with a standard normal distribution, this is how we'll be doing it, right? So you're going to use a random n function there, and it's going to be from -1 to 1. It's going to generate values from -1 to 1, whereas the rand function generates value from 0 to 1. Okay, random int. So this is again an integer function that we have. Again, just a repeat of the function that I wrote here, right? So that's there, and in case you want to give it from 1 to 100 and 10 digits, then you just give another comma and then get that value there, right? So array attributes and methods. So np dot arrange integer. We have two different arrays that we have here. Now, what are the things that we can do on top of arrays, right? So this is one array that we have here, one array that we have here, right? So 0 to 23 and 10 to 39. Now, what can we do with these arrays, right? We can basically shape these arrays. Now, I don't know if this code has finished running. I'm just going to say stop. Something not running this. Okay, my system has become a lot slower. Okay, I'm just going to continue. Basically, if you have your system and you're running it, just look at that particular number, right? So basically here, you're going to have you have 23, 24 numbers, right? So what you can do is you can reshape, right? So for example, you can just put 5 here and you got 25 numbers. Okay, David, yeah, and I can close some apps, but my office processes are running, so I cannot close it right now. Just how it is. Cool. Okay. Anyways, guys, so I'm just going to continue it. The reason this is error is showing a point. So basically, you have 25 values, and then if you want to reshape it to a 5 by 5 matrix, it's not going to do it, right? So you'll have to basically, so if you have 24 numbers, it's going to be like 6 bar 4 or 4 by 6 matrix, right? Or you can get 25 numbers to get a reshape of 5 by 5 matrix, right? So, but basically, it's what's going to do is it's going to take this long single dimension array, and then it's going to convert it into an array which is a 5 by 5 matrix, like such as this particular guy, right? So that's the advantage of your reshape function. So it basically casts that array to a more matrix format, right? And what are the other things that we can do? So we're going to use this particular array. We can get the max, we can get the argmax. Now argmax is basically which position is the maximum value presented, right? So it's 0, 1, 2, 3, 4, and this is the position where maximum value is present. You have min, then argmin, then you have shape, which basically tells you what's the shape of the array, right? And then we can also use reshape to convert it into an array that in a shape that we want to do, right? So reshape dot shape is going to be 1, 25. Previously, this is 25, 1, right? So that's how shape and reshape is going to be helped. And shape basically helps you just get a shape out of it, right? What's the shape of that particular array? Okay, so that's reshape 25, 1, 1, 25. This is fairly or across. And then, okay, just the shape of it will give you 25, 1, right? So this is basically multiple ways of playing around the data, right? And then last but not least, this is we end up using a lot of these. So arrays data type, right, can be accessed by saying .d type versus looking at the array in the previous example where it is mentioned in the front. Here you need to basically say .d type to get a data type here, right? So that's basically in a nutshell your NumPy arrays. Anyway, so what we're going to do in this particular session is go through certain portions of NumPy that we left off. Right, and then what we'll also do is we'll begin with Pandas, and hopefully we'll cover some good ground around that also. Okay, so let's look at NumPy indexing and selection. Now, so we have already seen some forms of indexing and selection already, right? So when I mean some forms of indexing and selection, if we have a certain array and we want to select portions of it, we basically can do it through the square bracket that we've already seen, right? So we have seen bits and pieces of that already. Now we're just going to blow out in certain areas and see what we can do in that, right? So in this particular case, I'm going to use this one, NumPy indexing and selection, right? And in case, so if you have that same file, we'll continue this, okay? So I'm going to create a sample array. Array is equal to NumPy dot arrange 10, 0 to 11, and then I can get an array from 0 to 10, right? So basically 11 elements within it. So broad bracket indexing and selection. So the way we, looking at this particular thing is that if we do a selection with a square bracket, right? It means that we are basically selecting it by an index, right? So 8 is the index value of this particular array, and then what is in the 8th position, that will be the one that we will be getting, right? So if I run that, I'll be basically getting 8 there, right? So of that particular array. Now, if I run, get a series of value, I can also use the colon bracket. The colon symbol here, and then get those elements, right? So 1 to 5, this is how we get it, right? Then if you want in a range, obviously 0 is something that it starts with. So just wanted to ensure that you know that your indexes start from 0 by default, right? And then we have broadcasting, which we have seen earlier also. So for example, in this particular case, I'm taking a slice of array that is 0 to 5, that is this particular array, right? And I'm assigning 100 to it. So when I assign 100 to it and then show the array, I'm going to get 100, 100 in the first 5 elements, and then rest of the elements will also be present, right? Now, if I just reset this array, and then I'm going to take the same slice of array, that whatever broadcasting we did, right? What we're going to do is, instead of like assigning the values directly, I'm just going to take a slice of array from the array that we have, right? So 0 to 6, let's say. And then when you look at the array, you'll get like 0, 1, 2, 3, 4, 5. Now, if I broadcast it on this particular array, and notice how I broadcasted it, I basically said colon, which means just take all the elements that are available in this slice of array and then replace it with 99. And then you basically get an array which has 99 all across, right? Now, here's the thing. Now, if I have this original array, and I took a piece of it, and then I sort of replaced it with 99. Now, when I look at the array that we have, you'll notice that it also replaced the values with 99. Now, why does this happen? Now, Python likes to keep things, save memory wherever it can, right? So unless we like explicitly mention that we are going to take a separate copy, Python assumes that whatever data set you're creating, right, in a temporary basis, it's going to impact the original data set, right? So for example, if I do anything on slice of array here, it's going to impact my original data set. And that's the way Python tends to keep things consistent, right? And this is very important topic when we are dealing with a lot of data files, especially when you can easily overwrite your data, and you'll not even notice sometimes that you have overwritten your data, right? So with and then overwritten, and then like if you make changes in one place, we want it to reflect in the root or the source databases, and that's one of the things that that's one of the things that we can do with. I'm just going to repeat it. I'm just going to take another portion here. So I'm going to reset the array here, right? And I'm going to take again the same array, but it's probably this thing, and then I'm going to just take the 3 elements, right? So I'm just going to take 3 elements, right? So in this particular thing, I'll be saying like say 3 elements, right? Now what I do is I just replace 99. I want to replace this 3 element that you have with 99, and then look at the array, right? So if I replaced it, obviously I got 999, 99, 99, 99 3 times. But then now when I look at the original array, you'll see that it has been replaced with 999. That's because we did not mention to Python explicitly that we are actually copying it, right? So Python assumes that if you're taking a slice of array from an array that we have here, it should ideally change it in the source array also, right? So that's how this logic works. So the next question obviously is how do we copy it, right? Obviously, and this particular thing that Python does avoids a lot of memory problems, but then we still need to copy, right? And the simple solution is that it should be an explicit call out, right? So if you want a copy of an array, you just say array.copy, and then you get a copy. And now whenever you modify this particular array, right, it's not going to be modified, right? It's not going to modify the original array, that is ARR, right? So that's how these things works. And the same logic essentially works on data frames also. So if you're trying to get a data frame and then get a copy of a data frame, and then you try to modify certain portions of it, it's going to reflect in the source data set, right? So you'll have to explicitly call out when you need to copy, right? So that's some of the things that we want to do, right? Now getting into indexing is something, again, we've seen how default indexing works, right? It begins with 0 and ends with whatever is the last value that you have. But you can also index within a 2D array also, right? So just like a matrix, or let's say, assume things on a coordinate geometry where you have X and Y axis, and you have like 4 coordinates where you can locate a value, right? So quite similarly, you basically have a row and a column way of looking at the arrays, right? So if I run this array, gets an array, and if I say in this particular array, I just want the slice in the first slice, it's basically going to give me an array versus going to give me a value, right? So in this particular case, when a 1D array, you're just going to get a value, but in this case, you're going to get an entire array as an output. How do we then like dive into getting an individual element? So what we do is assume that this is an array, right? And on top of it, if you put a square bracket, you're basically accessing the output of the array and then getting an individual element, right? So for example, here, if I just take a step further, I just got the first this particular array, and from that particular array, I want the 0th element, right? And if I get that, it's going to be 20, right? So from here, 20, 25, 30, and then we have 20 in this particular element, right? So we get that 20, and then we are able to see it. Now, obviously, this is one way of doing it, and there are multiple situations where we end up doing it, but there's other way of doing it is quite similar to your coordinate geometry. And notice again, the square bracket is getting used here, right? So we are very used to putting round brackets, but here in this case, we're just going to use square bracket to, slice and dice a particular NumPy array, made be 2D array or a 3D array or 1D array, right? So whichever it is, this thing. A bracket and then I gave the values, and then plus I gave a list within this particular array, right? So it by default this guy was a 2D array, right? Versus I just taking this entire element saying 5, 10, 15, 20, 20 like that. So I basically give it in that format. Okay, so moving forward now. So 2D array slicing, obviously now this is a game changer, right? Now this is where a lot of people get confused. It takes time to understand how to slice that particular portion and all that, but let's give it a shot, right? So I'm just going to fire up Excel for some time. Okay, so in this particular portion, right, we basically have things like this. So if you have, let's say 5, 10, and 15, right? So we basically have this sort of array that we have here, right? So sorry, this will be 220. And then right, so we have these elements with us, right? And we basically want a slice of this particular element right now. So when I say slice, it's basically saying, :2, :1, comma 1, colon, right? So basically what I'm saying is from just take from whichever is the beginning till 2, right? So till 2, I want certain elements, and then from 1, I want all the elements, right? So basically this particular portion gets selected, right? So how does this portion get selected? If this is your 0, 1, and 2, and again this is your 0, 1, 0, 1, and then 2, right? So what we did is we told we want till 2, right? So till 2 row would mean this particular thing, but -1, right? So for example, till here, right? So till 2 would mean this here, 25 till these two rows, right? So that's the thing. And then 1 colon, that is 1 colon. So you begin from 1 and then say colon till the end of it. And that's the array that you selected, right? So basically you're selecting a sub portion of it and then getting this value here, right? So I'm just going to quickly have another array here. Let's say okay, this time I took this particular array, right? Now if I wanted this particular portion, guys, what do you think should be my code? So I just want this particular portion. What do you think I can write here in row comma C format? 2 colon 4, yeah, 2 colon 4, 3 colon 4, okay, 2 colon 4, yeah, and then 1 colon 2. Okay, so let's see if that will be the right answer. Okay, so let's create another array here. and I basically have 5 rows and then these many columns, right? So I'm just going to say so we have 4 columns. So then 5 rows. So we'll take these things also. Yeah, so this is roughly the array that I have there. And then obviously I want a certain portion of it. So basically what I'm going to do is I'm going to say array underscore new, right? And then I'm going to say 2:4 comma 1:2, the last one that we have there, right? So we basically got 40 and 25, right? So basically this should be just 3, right? So 40, 45, 25, 30, right? So basically when you have till 3, right, it's basically n minus 1, right? So basically 3 minus 2 is 3 minus 1 is 2. So then that's the portion you'll be getting, right? So just remember, when you're using till that value, then you're basically getting that portion. Okay, so I'm just going to give one more problem on this. Okay, so this one we got it. How about this, guys? So I want this particular portion. So how do you think I can get this one? Now this concept is very very important when you're doing test and validation stuff, and then also trying to divide or slice the data also. Till 5. Yeah, so Shukal, till 5 will not be there, right? Because we don't. Yeah, so that just the colon and then 1:3. Yes, exactly. So let's look at that. I'm just going to put, let's say, all of the values you have here and then 1:3, right? So we basically get this portion we have there, right? So that's the way to deal with it, guys. And obviously this is going to be a lot more complex when you're slicing and dicing data, because you'll have a lot of columns and you'll have so many rows that you have to be very specific on what kind of portion you want to extract from a certain data, right? And very, very helpful in terms of there. There are some fancy indexing ways. Again, these are just things that we have here, right? So we basically have an array such as this, and then so we basically want to select a certain portion of it, but the way to do it is basically, if I have this particular array and then I give another array with it, right? So basically a list of values within it, right? That is 2, 4, 6, 8. So basically 2, 4, 6, and 8, right? We are able to then interleave certain values and then select it also, right? So versus in this case, you always are reliant on, this sort of a portion, right? I mean, continuous portion. But what if I wanted certain things like this, right? I wanted this, and this, right? So now obviously you can't use these notations, right? So in this case, what you can do is you basically send a list of indexes that you want from this particular array, right? And then so you can basically select it like that, and then you can also change the order that you want to select. Look at in this particular thing, right? And then we have selection. Basically, now this is where things get very interesting for when we want to do things with data frames and all that. But the NumPy way, the array of way of doing it is this, right? So we basically have an array, again 1 to 10, and if I just say array greater than 4, what it's going to give me is an array with trues and false, right? So it's going to run through each of the elements and compare it and then give me a value here, right? Now, so far we did indexing, right? So indexing based selection. But now what we're going to do is selection based on certain criteria, right? Now, in this particular case, obviously you got that value. And then what we can do is store all these Boolean arrays there. And then, with that condition, right, we just replace it in a square bracket here, right? So essentially what's happening is you're getting a list of values such as this, right? A list of index such as this, and then, this guy and this Boolean array basically helps us select based on the indexes that we retrieved based on the criteria, right? So essentially what it's going to look like is if you want a certain portion based on a condition, you're just going to give array within array greater than 2, right? So it's basically going to feed a value of trues and false, and then it's going to return an array based on meeting that criteria, right? Now, this is a very common scenario where in SQL you'll be dealing with things like select star from where is the condition, right? So where certain column greater than 2 or greater than between these two and all that, right? So there's going to be a lot of conditions that we are going to write within this square bracket, and basically just remember it gives you a Boolean array which can then pass through all of the elements and return the elements those are true, right? So that's how this selection really works. Now again, this is a very rudimentary way of looking at selection, but yeah, this is where we basically do selection. Okay guys, so moving on. So that's about arrays, indexing, and selection, right? I mean, so we basically did all of that, and then and now we are able to look at that information, and then I mean, we should be able to ideally do this kind of thing. It's got a lot of powerful. So here's the thing, guys. I mean, introduction to pandas. Pandas basically. Oh yeah, that's very nice. Anyway, so coming back to pandas. Now, pandas basically whatever we can do on Excel, right? Ideally, we should be able to do it on a platform like Python. And pandas is that library that basically helps you do that particular stuff much more even better than Excel. Right now, the only difference that you're going to get from Excel and pandas is the ability to have it visually visible to you, right? It's not that ED is going to be completely code. Imagine doing Excel completely with code, right? So that's what the pandas is, right? And there are, I've been an Excel user for like 10 years, and then the kind of things that pandas can do much more quicker than Excel will surprise you, right? It only can surprise you, right? So if you're able to if you're willing to learn that way and then adopt pandas as a default, you're going to enjoy doing data science and be like the quickest guy on the block to do manipulate data, right? So pandas is so much important there, right? So we're going to cover series now. All the NumPy arrays and all that we list, all that we cover within what we say within NumPy was one piece, but within pandas we basically refer to series, right? So whatever list or arrays we have is going to be referred to as series. Now within pandas they're going to be a little different, but however pandas is built on top of NumPy, so you're going to see some similarities there, but the difference is that, you know, we are going to reference Panda libraries wherever, and then whenever we are referring to a single dimension array or a list within Pandas, it's going to be called as series, right? So that is one piece of it. Now, a lot of lists and arrays that we have seen from different packages or by default within Python, right? They will be available, but, you know, to be usable in Pandas, we should be able to convert it to a Pandas series, right? So a lot of codes that we're initially going to look at is going to be around how do we take the elements from outside different libraries and then convert it into a series or a data frame within Pandas, right? So then it becomes a data frame for us to be reused, right? So we're going to see a lot of those elements that are there, and then we're going to see data frames. We're also going to do missing data, you know, codes, you know, group by codes. Now, can anybody tell me what is group by within Excel? Any references to what group by will be within Excel? I will tell you a hint. It's in the insert tab. Yes, pivot tables, exactly. And the other way, the another function that we have is basically summary function, right? So basically you'll have a function called as sumifs, right? So if you have there, you know, something like average if, count if, right? So all of these are summary functions, right? So they're going to be very critical. Group by again is going to be very critical there, right? So merging, joining, and concatenating, right? So merging and join are like pretty much the similar stuff, but the implementation or the way that we implement is a little different. Concatenating is basically, you know, placing one data below each other, right? Above, you know, below each other. So if you have a data set and you want to, you know, place two of these data sets one below the other, that's where we'll be doing it, right? So that's the premise in which we have. Then we have operations, like what can we do with two different data frames and what can we do on top of it, and then input and output here, right? Rather, I'm just going to begin with the input and output. That should be the first step, and then we'll basically do the rest of the things here, right? So I'm just going to be referring to this document right now. That is, it's called a data input and output, right? So can you all just open that piece first, and then I'll just show you some quick examples, and then um, uh, we can move on to the next topic there. Okay, so I'm not going to cover a lot of it, just few CSV imports and outputs, right? And just the Excel part. Rest of them are up to you to refer to. So basically we have this import NumPy as NumPy, import Pandas as PD, and we can basically import it just like how we did for NumPy. We have now Pandas as PD, right? And then if you want to import a particular CSV file, what you can say is you can basically have a variable name called as data frame, and then we say pandas.read_CSV example, right? And this particular example will be available here, right? So this is the Excel file that I want to import. So if I import that file, and if there is an extension, right? So if there is an extension such as this, you can just mention the extension and then import it, right? So if I run this code and then import my data set, is going to be in this format, right? So ABCD are the columns, 0, 1, 2, 3, 4 are the rows, and then you get these values here, right? So that's how you import CSVs, right? And we're going to import so many data sets there, but yeah, that's how we can begin it with, right? And then we also have, if you want to export certain elements, right? So what you can say is take the data frame and then say to CSV, right? And then give, let's say, export .csv, and then run this particular code, right? So if you run this, it's basically going to export that data set into Excel for us to reuse, right? So that's all I need you to know for now. We should be just be able to learn what goes in and goes out from this particular case. I hope that makes sense, guys. So far with me? So index is equal to false. So if you basically remember that 0, 1, 2, 3, 4, 5, 6, the indexing ways of selecting it, right? So if you do this, what it does is basically gets this index 0, 1, 2, 3, right? So we don't want this. So instead of deleting it here, we just say index is equal to false, and then it basically just exports the data set itself. Okay, cool. So that's all I need you all to know for now, just to be able to import and export, right? So within Excel, there is a little slightly different process. Excel can have multiple sheets. So it's but natural that you need to mention the sheet name, right? So you say sheet name is equal to something, and then you import it, right? So if you import it, you're going to get the same data frame, and then to export it, what you can do is you can give .xlsx and then also give a sheet name along with it, right? So that way you are able to export a Excel file also. Okay, cool. So let's move on to series then. So in this series part, there's going to be a lot of things that we're going to do here. So now this is a building blocks. This is just a single dimension array or list, right? But first we should be able to convert it into a Panda series, right? So that's what we're going to do right now. I'm just going to run through certain things. Creating a series. So what I've done here is I've basically taken different forms of lists, right? So I have certain labels, that is column names. Just imagine this as a column name, and then I have a list of values, just like one row within it, and then I also have an array, NumPy array, and then I have a dictionary also, right? So all of these things are fairly different things, right? So this is a list. This is again a list. This is an array from NumPy. This is a dictionary, right? So you have different elements available from the outside world, and now we're going to basically take all these things and convert it into the pandas world, right? So basically, what you can do is you can take a panda dot series, right? So that's how you access it, and then you say data is equal to my list. So you basically give this my list, and then you're able to basically create a panda series, and the panda series is, you'll see that it also automatically by default has a index, right? So you have 10, 20, and 30, right? Now pd.series data is equal to my list, and then index is equal to labels, right? So basically I can rename the indexes that you have here, right? So imagine, right, the one that we had exported here. So imagine this is the index, right? And if I want to change this index to something like, let's say, city names, I can basically say Hyderabad, Bangalore, Mumbai, Chennai, right? So all of these things can be renamed, right? So that index can be renamed within pandas, right? So, and that's going to be a crucial factor for us to manipulate a lot of things within pandas. So that's the thing, right? So we, with a list of values, we can convert it into series, but that series can then have an index of the user's choice, right? So that's a big differentiator in all of the list and arrays and all that we have. Um, and it's very similar to what we have within dictionaries, right? But a big differentiator in terms of what can we do with it, right? So similarly, I can convert say pd.series and say my list comma labels and just get rid of this data and index here, right? So that's how we can look at it. And then NumPy arrays. So basically, if you want to convert NumPy arrays, I just say pd.series and then give the NumPy arrays. pd.series gives arrays and labels, and then you're able to basically convert it into a series, right? With dictionary, it's very simple because all of the components are there within it. So you just say series and give the dictionary, and then you're just basically going to get this particular series here, right? What we're going to do here is that this is just an example, and you might come across certain examples, right? So within series, we can also store functions, right? So we can store functions. Now this becomes really important when you want to implement some dynamic calculations based on certain criteria, right? So, things like if certain criteria is done, then do a sum or do a average or whatever it is, right? So Pandas series can store built-in functions, which is again a great ways to use in multiple ways. But again, there are different other ways to do it. Hence, this is something that we are not going to directly use it, right? So that's one of the things. Okay, now let's get into some indexing part of it. Right now, obviously now what we saw was like the basic elements of how we can create indexes from labels and all that. But again, with indexes itself, there are certain things that we can do, right? So in this particular example, what can we do with this index is what we're looking for, right? So for example, here I have two different series with me, right? So I basically get a series with data 1, 2, 3, 4, and then the index we have is country names. Right? So series 1 has basically USA, Germany, USSR, Japan, and now this is where the beauty of Python will come in, right? And doing something like this within Excel would take a lot here, but within Python, it's just going to be very simple to do it, right? So you basically have another series 1, 2, 5, 4, and then you have USA, Germany, Italy, and Japan, right? So notice you have different names, right? So Italy is one name that you have here. USR is a different name here, right? Two different names. Now imagine, again, accessing remains the same here, right? I can access it by the index, right? It is same as you accessing it with 0 within it, right? But in the previous cases, but now since we have different types of index, we basically can access in the same way that we used to do it with NumPy arrays also, right? That particular logic remains the same. However, the difference comes, and the quickness comes with it, is that when you add these two series, it's automatically going to identify Germany if they are same, and then it's going to add the values within it, right? So that's how you get 4. And you see Italy is a new element here in the series 2. So it's going to basically say NAN because it doesn't really have equivalent element within that particular thing, right? So you have Japan, USA, if they're also available, so hence they got added, but USSR is not present within this, so it's going to be not available there, right? So basically what it does, it simply adds up, and then wherever the value is not present in either of the places, it sort of gets you NAN there, right? So again, a great feat within Python. And then again, as we know, multiple steps within Excel had to be done to get to this particular step, right? So that's the series. Okay, cool, guys. So in this data frame, now this is where data science begins. Up till now, it was just warm up. Now this is where things start off. Okay, so in data frames, again, so this is where like all of your data frames get handled here, right? And again, some of this inspiration comes from our programming language. So you're going to see a lot of references from that point, which is going to be really helpful. Okay, so again here, import pandas as PD, NumPy as NumPy as NumPy, NP, right? And then for no reason I've put this, but just ignore this for now. Just going to delete it, right? And then I have data frame PD is equal to read underscore Excel, right? So 3 underscore news underscore sales dot XLSX, right? So basically I have an Excel as this one, right? So I have this particular Excel file where I have north, east, west, and then the month available there, right? So that's one of the things that I have there. Now notice when I basically say import this news data set, right? I also mentioned the sheet name, right? So that's how I got the data frame available, right? Now, I can also basically say index is equal to and give the column name as month to basically import and then get this month as an index directly, right? However, if we don't mention it, we basically get a default index by pandas, right? Now, if you want to set that index to month, what you can do is you can say data frame dot set index month and say in place is equal to true, and then have it, right? So basically what this does is if you don't mention this, right? If you don't mention this, it basically doesn't it doesn't really change the index, right? Unless it's assigned to a different data frame, right? So ensure that you have in place is equal to true to make a permanent change, and that's how you get the change, right? So ideally, if you did, let's say, comma index is equal to and give the column name, you'll be waiting a data frame like this, where this is slightly darker and this is an index that we have generated for this particular data frame. Right, so far with me, guys? We're just on indexing a column, right? Now, ideally, we'll not have the luxury of creating, indexes, creating data sets, but you're just going to import data sets and then we have to choose one particular index there, right? So that's the idea here. Okay. Now, selecting an indexing within data frames, right? So I can take a data frame and say north, and then you're going to get the entire column information such as this, right? So if I run it, I basically get the entire information, and notice that I get Jan, Feb, and this thing as a index here, right? Because obviously, if it is indexed, you're just going to get that information wherever you go, right? So that information is just generally going to tell you till that data frame exists, till that index exists, right? So if I want two different columns, I can say things like this, north and south, and then it's going to give me that column here, right? So notice a square bracket with the column name with quotation, and then notice that I give a bracket that is a list of two column names from a data frame to get these two columns.
So yeah, guys, so basically this is Kaggle.com Titanic. Just log in and enter this competition. So instead of this submit prediction here, you're going to get enter this competition here. So enter this competition, go to the data section, right, and download these data sets, right? For now, just the train is enough. You can go here and download it, and then there will be test and gender submission. You can download all three of them, right? What we're going to do is try to import that within Pandas. So yesterday we tried doing it. I'm going to show you, but just try to import it within Pandas. So how are you going to do it? So you're going to go into the the solving I mean, I'm going into my folder, you can go into your folder, right? And create a new Python notebook, right? In fact, what I'll do is I'll just do it from the place that we can begin, right? So I'm just going to say Titanic, and I'm going to put train and test within it, right? So I have this one folder, guys, where I should be having train and test, and I'm basically going to create a new notebook there and call this as Titanic case study, right? And I'm also going to give date. Okay, so this is the folder setup, guys. I hope everybody is till this particular setup, right? So I have a test and train data set and a new notebook available within that place.
Okay. Cool. Okay, cool, guys. So now let's look at the problem statement. So I just want you all to open the train data set here, right, on Excel. And I'm going to tell you the problem statement. Okay, so I'm going to open this data set and have a look at this data set and tell me how many variables are available here. So how many variables are available here? How many variables and how many columns? Okay, 12 columns. Yes, so that is around 12 columns. Yes, so 12 columns and how many rows? How many rows? How many rows, guys? How many rows are available? 891. Yes, exactly. Right. So that's your data set. So let me just begin with the data, the problem statement here. And again, we're not going to do it directly, which first we're going to do the understand the problem statement and then, understand the data and then we're going to do it. Right. So basically we have a column, we have a unique passenger ID. You have passenger 1, 2, 3, and so on till 891. So that many rows and that many passengers are available with us. And we have their information, whether they have survived or not survived, right? So for example, just imagine, Jack and Rose. So if Jack's name was here, right, it would mean that he did not survive. And if Rose was there, basically she survived, right? And their age is basically given. What's their age, right? What is the gender, right? And then how many siblings or spouses they came with, right? So some of the data definition is given within the case study itself, right? So you have like this number of siblings or spouses on the Titanic ship. Parsh is basically how many parents and children on the ship with them. Tickets, what is the ticket number, what is the fare they paid, right, which cabin they were staying in, and which port they embarked, right? So there are 3 ports which they embarked with, right? So obviously that's something that you have there. And then you have P class, which is basically which ticket class it is, right? And they have given the definition here, where first is upper class, second is middle class, third is lower class, right? So basically that's the factor they have. Age is a fraction. If age is less than 1, that means it's basically a child, just born baby or something like that, right? And then siblings and spouse will be equal to brother, sister, step brother, step sister, husband, wife, mistresses, fiancés, were ignored, which means rows was basically ignored in this scenario. Right, then parse how many parents and mothers you have, children, how many daughters, stepdaughter, stepson, and so on, right? So some children traveled only with a nanny, so therefore parts will be equal to 0 for them, right? So that's the data that we have with us, right? Now we need to perform some primary exploratory data analysis, and then now we are equipped with pandas on Python, and then we're going to try to do some primary exploratory data analysis, right? And then we get to know what is happening within that particular thing, right? So that's what we're going to begin with, and let's apply some of the things that we learned about, and some of the new topics that we will be learning will also be covered within this particular data set, right? So let's look at that. The first first thing what we're going to do is obviously import the data set, right? And basically this is the introduction of the data that I gave you. Another thing I just want to go do before I get into this is that, so the problem statement really is, and whenever we come to that logistic regression statement, you'll see that the survived is not present within the test data set, right? So it's not present. Ideally it should be here, right? But it's not present, right? So the problem statement is that we should understand this data and build a model such that it will predict the survival rate of the passengers that do not have the survival rate, right? So either 0 or 1, it's going to be there. And it's basically termed as a classification problem statement, right? So Abdul, we're going to come into that. It's a classification problem. Basically, you are trying to, classify these rows into either 0 or 1, right? So that's a classification problem. And I'm going to learn more about it. But right now, the focus is around the data, right? So that's the problem statement. And just keep in mind that what we are trying to solve for is trying to predict or trying to classify all of these rows into 0 and 1 using the trained data that we have here, right? So that's the problem. Okay, cool. So moving forward, now let's import this particular data set into, let's import this data set into Pandas. So what do you do to get this particular data set into Pandas, guys? Right, so what is the package we dealt with yesterday? Can anybody recall? Read CSVs, right? So import pandas, right? So I want everybody to start with import pandas as PD. Can you all begin with this? Run the code, and then if you run the code correctly, there will be no errors, right? And then what we're going to do is create a train data set and call it pd.read_CSV, right? And then give it train.csv, right? Now note that in whichever place I'm writing the code, in the same folder the data set should be present, right? If it's somewhere else, you have to give the path and try to get that place, right? But ideally I prefer the data set and the code should be present within that, right? So I import the data set, right? So I import train data set. Okay, cool. So once we have imported the file, now I just want to see that particular file. What is, how many, what are the columns looking like and rows looking like, right? So just to see a snapshot of that table, right? I mean, exactly, we're not in Excel where we can see the data immediately, right? So to see that data and have a snapshot of what the data looks like, what I can do is something like this. I can say train.head, and it's basically going to show me a snapshot of the data set. That's right, Rishabh. So if I want to see a snapshot of this particular data set, what I can do is I can just give things like this, right? So I can just say passenger ID, right? ID, right? And then I can give survived, right? And P class, right? Age and SIBS and spouse. Right, and then I give parents and children, right? So basically I can get this particular data set. I can just call this as subset is equal to, right? And then I can say subset dot head, right? Which basically will give me a much more smaller version of the data set. Okay, cool. So now if I wanted to add a family column with this, guys, right? So I wanted to add a family column with this, right? I want to know the family size. So what do you think we can do based on whatever we have learned yesterday? What do you think I can do? I want the family size of that particular passenger. So for example, passenger one, how many family members are there, right? So if you add up, these two, you'll get that plus himself, you're going to get the family member size, right? Am I right? So I want you all to create a new column and bring out the family size with it. Right, so how do you create a new column, guys? Right, so if I want basically the family size, I'm going to give it like, say, your train data set, right? I want to create a family column, all right, and then equate it to, let's say, I want to basically, sum of two columns, right? So basically how I can do it is I can say train, right? And then give it, let's say, sibs sparse, right? And instead of placing it inside Himanshu or Abdul, what we can do is, to in the better aesthetics, what we can do is place it like this and then give it, right? So this is much more better. So I'm taking column one and then adding another column on top of it, right? Right, so we'll begin with this, right? Cool. So now let's look at this data frame, right? And then we'll move on to the next topic. So I'll say, hey, show me this train data set and show the head of it, right? So I'm just going to run this code and then look at it again, and you'll see that there will be another column that gets added that's called family, right? And I told family size is also including the one person that is there within this row. So if you add all of these things together and run the code, you're going to basically get the family size, right? So that's how you get the family size. Now, okay, moving on to much more, bigger things on this particular thing, right? Now, when we come to this particular data set, right, we basically are faced with a lot of things, right? So for example, I asked you about how many rows and how many columns are there, right? So we would want to begin with that particular thing, right? So this is just was a warm up of what we had done yesterday, right? So ideally you'd begin with, how many rows and columns you have within that data set, right? So there will be a way to look at it. Like can anybody tell me how to get the rows and what we say columns of that particular data set? So we know what is the data set we are dealing with, right? So we basically have something called as train dot shape, which basically will tell me what is the dimension, right? And not exactly shape, it should be there will be something size. Sorry, yeah, that is size. So basically, if you run it, you basically get the size. Oh, no need for the, sorry, shape is what I just don't have to give the brackets. Yeah. So shape, yes. So you basically get the shape. I don't have to give the brackets. My bad. So you get the shape, and you get like 891 rows and 13 columns is what you get, right? So basically, this train data frame itself will have a lot of things that we can access, right? So obviously, one of them is the train, and then we also can get the length, right? So length will here we need to put, okay, length is not there. Okay, just go to shape. That's it for now. Yeah, it'll be there in series. Yeah, so in this particular thing, it's going to be a shape, and it's going to be 891 and 13, right? Now, the other thing that we also have to look at is how many columns we have and what is the data type, right? So what we can do is we can say train dot describe, right? And then if you do it, you'll basically get this kind of summary, which gives you all the numerical variables summary, right? So it basically gives you a numerical variable summary, and then you're able to look at it, right? So what's the mean, what's the count, and so on and so forth, right? So those are the details that you'll be having there, right? And the last thing that we can also look at is something called as a info, which basically tells you about what are the number of columns that you have there, and what are the number of the rows that you have, and what is the columns along with what is that data type there, right? So for example, passenger ID has 891 rows, and it has what do you say, it is a data type which is of the nature integer, right? And so on and so forth, right? Now, by looking at this, can you tell me which of the columns have missing data? Now, whenever modeling is concerned, right, missing data is usually a big concern. So what do you think has missing data? The number of rows here. So look at the number of rows here. So if you know that 891 is the shape, right, 891 rows, if you look at this particular case and see if anything is missing there, right, you'll be able to identify it quickly. Am I right? So which variables are missing? Yes, age, cabin, embarked, right? So age, cabin, and embarked are missing. So here we have fair bit of missing values. Here we have cabin, here we have embarked, right? So yes, so these are the thing, and I've seen the others writing one more method also. So if you do is null, right, and these are some of the operations with this particular data set. If you do is null, right, you're going to basically get this sort of scenario here, right? Wherever there are missing values, you're going to find it, right? And then I don't know if you can sum this up, but if you can sum this up, right, it basically tells you where are how many missing values are there, right? So for example, I have age 177, and then cabin 687, embarked by just 2 missing values, right? So this is just the reverse of this particular scenario, right? And if I want to know what is the missing value percentage, can anybody tell me how to get this? Right, so far I got this, like, so I want to know the percentage of missing values within that particular data set. Divide by 11. Okay, let me rephrase the question, right? Okay, so I basically have this age column, right? So I'm just going to take, maybe I'm going to take this, right? I'm going to rephrase the question, and then you'll be able to answer what I'm trying to find. And then let's say this is the number of rows, right? So I have 1, 2, and so on and so forth. So let's say I have 12 rows with me. And then I identified that I basically have missing values like this, right? So wherever there is a blank, I'm going to put as 1, right? And then that's the meaning of missing, right? So what that step is doing is this, right? So basically it's doing is null dot sum is what's happening here, right? So it's basically finding out, and then you're basically getting all of these, and then if you sum it up, you're basically getting that 7, right? So it's going to be 7 here, right? So the sum, the number of missing values is 7 here, right? And if I want to know what is the percentage of missing values within this particular column, right? So what will be the denominator that you have here? So what will be the denominator that you have? 12, right? So how many number of rows, right? So that's your denominator. So if I wanted to know the number of missing values within each of these columns, what do you think we need to do? In this particular case, divide it. Okay, how many number of rows, guys? Just the number of rows we need to do, right? So I want to know by 891, right? So basically 20% values is missing here. Cabin 77% is missing, and then you're missing less than 2% here, right? So that's just the division that you need to change it with, right? It's just the trained data set's length is something that will help you get the percentage. Make sense, guys? So if I run this, I get the number of values that are missing, right? That is this particular case here, right? So this particular case, wherever there is a missing, right, Pandas sums it up and then gives me that particular value for that particular column. If you have multiple columns, it's going to get you that, right? So if you divide that, right, so that's the if you divide it by 891, that's the percentage you're getting here. Now this is very crucial for data analysis, because depending on the strategy, you're going to find out what are the missing values and then what we can do with it, right? So any suggestions? So next part is obviously understanding how we can replace it. But before that, right, I just want to do certain more data analysis, right? And that is basically the concept of yeah, okay, let's do missing data first. So I'm just going to introduce you certain concepts, and then we'll basically get into missing data treatment, right? So just wanted to keep just wanted to keep a certain theory on this part, and then solve this for this particular problem. So for example, here now we have age, right, fare, and cabin, embarked, right? Yeah, so embarked, cabin, age, right, are the variables that we need to treat, right? So missing data treatment, right? So before that, I'm just going to show you quick theory about missing values and all that, and then we'll work towards ensuring how we can get fill this or impute this missing data quickly. Okay, cool. So here's the part of missing data, guys. So here I'm going to use Pandas and NumPy. I just created a data frame, and that has basically A, B, C, D, and then you basically have numbers available here. That is the index, and you have certain values within this place, right? Now, within this missing data value treatment, what I want to do, what I want to bring focus to is that you can just say drop NA, right? Drop NA, and then it's just going to drop that column, that rows that have a missing value in it, right? So only the one that we have here, that will not have a missing value, right? So basically, you can note here that these two have missing values, hence it's just deleted it, right? Now, if you say missing value drop NA along axis, so what it's going to do, it's going to delete A and B, and then just retain the C column here, right? So that's what it did here. So that's the drop NA. By default, it drops the rows. But if you want to drop an entire column where there is missing value here, you're basically going to have the columns getting deleted, right? And then there is also something called as a threshold. So if you have more than like two missing values within that particular row, then you basically delete that entire row, right? So if you see in this particular case, you have two missing values in different columns, and if you mention the threshold, it's basically going to delete it, right? So that's the second row that got deleted, right? And this is one of the most important part that you're going to do, right? And this is how we are going to deal with missing values within our data set also, right? So if I'm saying data frame dot fill NA value is equal to fill value, right? What this does is wherever there is a missing value, it just fills it with a certain value there, right? And then if you want to be very specific, right? So in this particular case, let's say I want to replace this this value here with the mean of the A values here, whichever values are present, right? So what I can do is I can say data frame dot column A, and then say dot fill NA, right? Whatever value I want to place, I can say that, and then I can say give me the data frames columns mean, right? So that's how it does it. And then basically what it does, it takes 1 plus 2 divide by 2, that is 1.5, and places it here, right? So that's a missing value treatment. So anywhere data science involves, right, missing data value treatment is going to be one of the cases. And obviously, to be dealing with missing data, drop NA and fill NA is one of the key things that we're going to be using, right? So let's apply this to our case, right? So any suggestions on how we can impute age? So when I say impute age, that is a new terminology there. I want to basically fill all the places that are missing value with the mean. That's one of the ways to do it, right? So let me just show you for the demonstrative purposes what it's going to look like in Excel, right? So basically what happens is if I have this age column, right? So let me just pick out this age column here. I'm going to place it here, right? So I have this age column and I basically need to fill this place with the mean, right? And just let me do a couple of more here, right? So I want to place this with the mean of the age, right? So first, for that, what I have to do is at least find the mean, right? So I'm going to say mean. Okay, I have in Excel, it's average. So you basically select the average here, and I got the average as 27.6. That is a much more later stage. Okay, anyway, so here, what we're going to do here is, so what this Python code does is, if this value is equal to, right, blank, then fill it with the mean here, right? Else just put this particular value, right? So when I do this, you basically get a column that has missing values imputed wherever there is a missing value available there, right? So for conceptually, you got what's happening here, guys. Now we're going to do the same thing in Python, right? So we're going to achieve this within Python, right? So we know that age is missing, right? Age is missing, and I'm just going to stick with this train.isNull.sum to know what are the missing values there, right? So we know that this is the missing value here, right? So I want to replace it with the mean or median, right? Sometimes medium, I've seen a lot of cases, medium has worked best. So what we will do here is that I'll say train, right? And then I'll say, I want to replace age with the mean wherever that mean is present, right? So obviously not equal to, say, dot fill NA, right? And then I'm going to fill it with train the age dot median, right? And it can be mean also, right? Whichever it is. So what this does is basically replaces wherever just filling the values wherever there is a missing value within age. It's just going to fill it with the mean of this, right? And then just to show you what's happening with this part, I can just simply run this code. It's going to give me a median that is 28, which I'm going to use it within this data set, right? So if I run this particular code, it's basically going to give me this 22 point so on so forth, right? So wherever there is missing value, it's going to be replacing it 28, right? The last step that we need to do is we can say that put this back into the column age, right? So so what happens if you do that, any column, any rows that are missing values within the age column, right, they will be replaced. Now how do we check this? I'm just going to copy this and paste it here, right, and run this code, and you'll see that age suddenly has no missing values there, right? Okay. Okay, cool. So we've got that information now, obviously. Now the next part will require certain theory also, right? So it's basically, group by is something that we need to know, right? So if I want to know how many, how many times S occurred within the data set, C occurred, or Q occurred within this data set, right? I want to count of rows within this thing, right? In pivot table, you would actually be doing it with like this, right? So you take embarked, right? And then you take count of passengers, and then you'll be able to get the CQS, how many of them, how many of them occurred, how many times within that data set, right? So this is basically called as getting the frequency of a data of the rows of the values within that particular column, right? So that's something that we are looking at. And as you can see in this example, two of them are missing values here. Two of them are missing values. So basically what we do in this particular case is that we replace it with the one that occurs most, right? So if S occurs most, right, we're going to replace it with that particular value, right? So now the problem statement here in this particular scenario is I should be able to identify which of them has, which of them is occurring most within this particular embarked data frame, embarked column. So there is this concept, it's called these values count, right? So whatever we do with the pivot table here, right, can be gotten by values count. So how do we do that? You basically take this frame here and then call it as embarked, right? And then I can say values underscore counts. So if I run this, it's going to be value count, sorry. Embarked count, sorry. I always add an. Okay. Did I spell that wrong? Capital E. Yeah, so basically when you do that, you're going to get this 64, 168, and 77, which means S is the most occurring one, right? So now if you want to basically replace these two rows that are there, right? So these two rows that are available here, right? So in this particular thing, what I want is this particular row, this missing value should be replaced with an, what we call it? We want to replace it with S. So how do we do it, guys? Yeah, mode. So if I do this particular thing and say mode, it's going to give me an S here. Right? So that's the value we need to be replacing it with. So okay, cool. So obviously now we have to replace it with the mode. So I'm just going to copy this code and just paste it here, and I'm going to only replace it. Copy this guy, paste it, and instead of median, I'm just going to say mode, right? So if I run it, it basically replaces it with the mode, right? And if I rerun this code, right, ideally what should happen is this number should be increasing by 2, and this is null. This 2 should become 0, right? So let's see if that happens. If I run this again, embarked still did not get replaced. Embark.mode. I guess it's showing 0. Okay, so we basically have an object with S in it. We just, so basically it's getting this particular 0, suppose, which is why it's not replacing it. Okay, for now, let's just get along with this, right? So we replace it with S. Let's keep it simple for now. What we do is we replace it with S, and then if you look at this value, you'll see that the embarked is basically gone, right? So idea is to replace it with whichever occurs most number of times, and then you'll be able to get replace that particular value, right? So basically all of the missing values are gone. there is only one more left. There's this cabin, right? So for this, we cannot really get rid of this column because that's a crucial information. So what we'll do is for cabin, yeah, I mean, we'll not delete it. We will retain it. There is a way to deal with it. So I'm just going to say cabin, and I'm going to call this as missing, right? And we're going to deal with it separately in the what we say when we are doing feature engineering. But ideally, what will happen is what I'm doing in this particular scenario is that wherever there is a missing cabin here, right? All I'm doing is basically selecting this entire column, saying wherever there is a blank, right? Fill a missing value there, right? So that's the idea here, right? So you basically filled it with missing so that we can deal with it in a much more better fashion versus having it blank like this. So I will tell you how this is useful. So if you look at this thing, right, now let's look at the value counts of that particular thing, right? So again, we will basically look at the value counts. Now, how is it going to be useful is that, any questions, Himanshu? Okay. So basically, so far what we have done, we've imported the data set using pandas. We saw the head, right? We tried to select certain columns out of it, right? And then we basically also saw created a new column called family using 2 columns. And then we also saw multiple ways to see the data frame size, the ways to basically describe a data frame, right? Saw some info, right? We also looked at how we can find out missing values, did some missing value treatment for age, right? And the categorical variables. And then we basically have a clean data set with us that will be helpful for modeling, right? So at this point, we basically did like whatever we could do in this particular thing, right? Now so I want to get the average age by P class, right? So how do you think we can do it, right? I want to get the average age of P class. I want to see which of this P class has, what is the average age of the P class. I would expect that, the P class 1, the higher class should be a little older. So let's see if that is true or not. So how do you get the average age of by P class, guys? Okay, so I'm going to say train dot P class dot group by, and then what do you do, guys? Rather, I'm just going to do it like this. P class, and then if I run it, it'll give me this object, right? But I want to get the sum. Sorry, average. So I'm going to say mean, and if I run it, I'm basically getting the mean of it. And I just want the age, right? So I'm just going to say age here. So I got the average age of P class, and you see that as we expected, the average age of P class is much more 1, that is the higher class is much more high than the lower classes, and it's going down, right? So I also want to check, right, what is the mean of the fair, right? So you can see that P class 1 clearly has an average, has a high average age, but they're also paying a higher fare, right? So they're also paying a higher fare than any of them, and it's significantly high. It's like 4 times this thing, and there's no difference. There's little difference between the lower class and the middle class, but again, you see middle class is like not just above what we have here there, right? And you can see a lot of the third class people, right, have a higher point, the average of siblings and spouses. So basically they are the ones who are traveling with maximum family members, right? So that's how we look at it. And you can see that the family size on an average is 2, which is larger than the P class 1 and 2. Okay, so far with me, guys? Makes sense? Make some business sense? Okay, cool. So now that we know group by, and you also know group by, we have applied it, right? Now I want you all to basically write a code to tell me which gender has a better chance of survival. Yes, okay. Okay, so let's do that. So I'm going to take this, I'm going to survive, I'm going to do this, and I'm going to just do, sex here, right? So I basically get this survival factor here, right? So on an average, right, the survival, this thing is 74%. On males, it's 18%. So can you see the difference here? So that is by the mean. So if I do the sum, you see I got the sum of, so there are 200 and, 233 passengers that survived in females, and then 109 survived in males, right? So if I get this value, obviously, you're basically seeing that, yes, there are more number of female survivors, right? But we need to then divide that, right? So basically, if I do 233 divide by how many number of females and males are there, right? So how do we know how many males and females are there within this data set, right? So how do we know how many males and females are there? Values count, yes. So values count. So I'm going to say train dot value counts, right? So if I do this, you're going to see that females are 314 and males are 577, right? So if I just do 233 divided by 314, you're going to get that 74%, right? That average that you had seen earlier, right? And then if I just do like 109 divided by the number of males, that is 577, right? It's going to be 18, and which was the average that we had seen earlier, right? So if I just do this average, it basically amounts to the same answer there. Not exactly same, but similar. You'll be getting it there, right? I think so. It's exactly same also, right? So that's the average that you're getting there. Okay. So far with me, guys. So this is still group by, guys, right? So we have covered a good ground in terms of theory, right? Missing value treatment, summarizing data, right? So you're going to see, you've seen it live, right? Now we're going to put it all together, right? So remember, we started with trying to solve the problem for how many passengers survived or not survived, right? So what I'm going to do is go to the folder that I have the Titanic problem. I'm going to open the test data set. So if you have not opened the test data set, please open the test data set, right? And what you can do is you can put survived here, right? So I'm going to put survived here. Now, what was the thing that we did here there, guys? We did that if a passenger is female, right, they have a higher average or higher probability of surviving, right? And this, we proved it, right? We saw that 0.74 and 0.18 is the higher chances of survival, right? So what I'm going to do is I'm going to round off this to 1 and round off this to 0, right? And we're going to get a classification here, right? So for example, if this is equal to female, then 1, else 0, right? So that's the thing. So if this is a male, it's going to be 0. And then if I drag it down, I basically have a model where I'm able to predict whether this passenger died or no, basis the probability of gender here, basis the probability of gender survival rate. Okay, cool. So then open a new data set, right? And just take these two columns with you. Say copy, right? And just don't paste it here. You're going to get everything 0 here, right? Rather say paste special values. Copy paste and ensure this value is summing up to sum up to 100 and 152, right? And I also like to click on this Excel and say numerical count minimum and maximum. So it shows me a lot more stats available with here, right? So you can see that I have this sum 152, right? Then this is the right file. Then what I can do is I can say save as, I'm going to say in Titanic, and save this as a CSV file, right? Don't save it as an Excel file, and call this as a gender submission 1 or whatever you can. Okay. So now once you have done it, you can close it and go to the Kaggle website. And here's the first. So what you're going to do is going to submit the first prediction of your Kaggle listing, right? So you can select this, right? Go to the folder where you had this file. So I have this gender submission, select that file. And submitted the competition, right? A brief description if you want to write, and just say first submission or something like that, and say make submission, right? If you make submission, you should get a score for your model. I want to know what that score is. I've already submitted multiple times. So I'm just going to go to my submissions. And I have this submission available here. So what are you getting there? You have it like this, right? So what you can do is select this A and hold the control key and select this L, right? So what you can do is then copy and then say click control N and then paste special values. So you'll get just these two columns. Right, so you just get these two columns and you will have basically 419 rows within this data. right? So this is just the basic model of what we did. Yeah, only these two columns, right? So in this C, we expect the solution file to have 418 prediction rows. This should file have a header row. Please see the example, right? So if you go to this data page, right, they will give you a sample, right? So if you select the sample, right, it's basically this particular thing, that is the passenger ID, right, along with the prediction, that is the survived, right? So these are the two things that it will take. So when you upload, right, so this is the file it will be looking like, right? Just passenger ID and this. So guys, just reiterating the problem statement, we have a data set, that is a trained data set, where the survival details of the person and additional details are present. In the test data set, right, the survival details are not present. We build the model based on whether checking the chances of whether if that person is female or no, right? Because you see that female has a better chance of survival than males. So basis that idea, we built, we predicted whether this particular person survived or no. And that's what we submitted to Kaggle. Okay guys, so that's it for today.